All right, we're continuing with solving radical equations. And in this case, we have actually some questions where we have two radicals. So I'm going to look down here, have the steps here. So we want to isolate the radical. If there are two radicals that aren't alike, we usually isolate the more complicated one. So we have two radicals. We want to isolate one of them. In this case, for number 6, I wouldn't say either is really all that more complicated. More complicated, I would say, has 3 terms compared to 2 terms. So we're going to go ahead, since this one right here is negative, we're going to go ahead and add that to both sides, and we will isolate this one. So we're going to add the square root of 7n minus 3 to both sides. And that'll give us root 5 minus n equals, and I'll go ahead and put this first, 7 square root of 7n minus 3, because we have the minus 4. And I like this negative second. Now that we've isolated one of the radicals, we're going to go ahead and square both sides. On the left side, this turns out nice. This cancels. That's what we wanted. We're left with 5 minus n. Now what I've been doing, remember this 2 terms here. When we square 2 terms, we have the special way to multiply that out, or we can just think it is multiplied by itself. So 7n minus 3 minus 4 multiplied by the square root of 7n minus 3 minus 4. We multiply these out. Well, when the square root's multiplied by itself, you go ahead, the square root is gone, it cancels, so we have 7n minus 3. Next one, we're going to multiply here, so this is going to be negative 4 square root of 7n minus 3. Now we're going to take the negative 4 here, which actually gives us the exact same term as before. And then lastly, we'll do negative 4 times negative 4 is positive 16. Well, we notice here we have some like terms. So let's get those. We have the negative 3 and the 16. And then we have the 2 square roots are like. So when we add these things together, we'll get 7n. 16 and negative 3 is 13. And then negative 8 times 7n minus 3, square root of 7n minus 3. And we'll put that over here with in our question. So it was 5 minus n equals 7n plus 13 minus 8 times the square root of 7n minus 3. So we're down to that next step where it says if there's still another radical, go ahead and start over at step 1. And we do still have another radical, so we're going to isolate that radical. So let's go ahead and subtract 7n from both sides and subtract 13 from both sides. And this is going to give us negative 8 minus 8n equals negative 8 times the square root of 7n minus 3. Now, this negative 8 here multiplied by the square root of 7n minus 3, we do want to isolate the radical, so we're going to go ahead and divide by negative 8. If it doesn't divide nicely into the side, if it's not a factor, you don't have to actually divide by the negative 8. You could keep it there. But when you square both sides, you want to remember to square the 8 also. But whenever you can simplify, it helps because it keeps your numbers smaller and easier to work with. So let's go ahead and divide both sides by negative 8. And that gives us 1 plus n equals the square root of 7n minus 3. Well, we have a radical isolated again, so let's go ahead and square both sides. 1 plus n squared is 1 plus n times itself. Remember, we could think through the nice pattern that we have to multiply these. But here where I'm just showing you multiplying it out. So we got 1 plus n plus another n plus n squared. And so when you multiply this out, we get n squared plus 2n plus 1. Over here it cancels, so we have 7n minus 3. And we're left with a quadratic, so we're going to bring everything to the left side to solve that quadratic. We'll do that. We'll subtract 7n and add 3 on both sides. And that gives us n squared minus 5n plus 4 is equal to 0. We're going to factor that. So in order to get n squared, we need an n and an n. In order to get a positive 4, we need either 2 positives or 2 negatives. We know it's 2 negatives because this one's a negative. And the factors of 4 that will get us to negative 5 won't be 2 and 2, it will be 4 and 1. So we have negative 4n minus 1n does give us this negative 5n. And so we see that n is equal to 4 or 1. Of course, we want to check our answer because we squared both sides. So let's check. We're going to try putting in 4 into our original. So we have the square root of 5 minus 4 minus the square root of 7 times 4 minus 3. And we want to see, does that equal negative 4? So this is the square root of 5 minus 4, square root of 1, minus 28 minus 3 is 25. Does that equal negative 4? Well, 1 minus 5 does equal negative 4, so that worked. So 4 is one of our answers. Let's now try 1. So we got the square root of 5 minus 1, because we're plugging in 1. And we're going to put that into the next part. Oops. So minus square root of 7 times 1 minus 3 equals negative 4. We're going to see if that works. So this is the square root of 4 minus the square root of 4. Does that equal negative 4? Well, no, that's going to be 0. So this is not true. And so our only answer, so 1 didn't work, our only answer is n equals 4. So I know that's quite a process, but follow those steps as you work through 5 and 7. We're actually going to look at number 8 because this one has it's kind of a special case, and it actually can be really easy if you at least take a glance at things first and see what's happening. So looking at number 8, we have a square root over on the right side. And there's no sign out here, so it's a positive square root. So this is like a plus over here. So this has to be a positive. So over here is a positive. On the left, we have a negative, because negative 4 minus some value here, which is going to be positive, is going to be negative. So we have this is a negative. Can a positive ever equal a negative? Well, the answer is no. So there is no solution for this one. So as you work through these questions, you might just want to take a glance at it first and make sure it's going to make sense. It saves you a lot of time doing the work. It's fine to get the practice doing the work, but in this case, this is no solution, and we can get to that pretty quickly. So there